Okay, we're recording. So we're looking at paper 3, 2017. Well, let's just zero our calculator for the moment. We don't need that on there. Calculator paper. Let's get cracking. Okay, question number 1. Asadullah, please. All right, question number 1. Remember the first couple of questions from the higher paper will be the overlap from the foundation paper. So the questions at the end of the foundation paper will be the beginning questions of the higher paper normally. So question number 1, let's read please. Mr. I think it's Asadullah, isn't it? Asadullah, come on mute please. Hopefully he's still there. Okay, looks like Asadullah's gone somewhere. Let's have Eliza. Eliza, join us on question number 1. Read. Do you know what that E stands for? Okay, I think everybody's gone to sleep. Oh, hang on a second. Oh, sorry, that's me, Brad. I've done the master mute. Okay. Allow participants to unmute themselves. Okay, let's try it now. I think everybody's going to be unmuting at the same time now. Okay, Abdullah, can you unmute now then?
Yeah, Asadullah.
Sorry, Asadullah. Asadullah, can you unmute yourself? Okay. Everybody should be able to. Can you unmute yourself, Salia? This is yours work.
Yeah.
Okay, that's excellent. Okay, Asadullah, are you there, mister?
He probably hasn't got a mic or something.
No, I don't know what it is.
It allowed me now. It wouldn't allow me before.
Okay, wake up. Come on, let's get started. Come on. What does the E? What does that funny E stand for?
I'm not sure.
That's the whole lot. Okay, then you have set A and set B. So we need to label our diagram. So which one should we call A and B from our circles?
You can call either of them.
Correct. There we go. So E is the overlapping the whole lot. Sorry, the E is outside the circle but inside the rectangle. So E includes everything. So E is all the odd numbers less than 30. Can you give me the odd numbers less than 30, please? What are they?
3,
1, 3,
5, 7, 9, 11, 13, 15, 17, and 19, 21.
Okay, it's going to be less than 30, so we can keep it going.
23, 27, 29.
Okay, so them are all the numbers that should be in the question in total, not more than those numbers. Okay, now A is 3, 9, 15, 21, 27, and B is 5, 15, 25. Are there any overlapping numbers in this Venn diagram question?
Yeah, 15.
15. So where does 15 go then?
In the middle.
15 will go in the middle, absolutely. So if 15 goes in the middle, what's left to be in the B circle?
5 and 25.
Fantastic. So that's all been done now. So we can even cut them off from here as well. 15. We've done 5. And we've done 25. Excellent. Now, what about that's 15 done? So what's left in the A set?
21 and 27.
3, 9, 21, and
27.
Fantastic, lovely. So the circles have all been populated by the numbers in the correct position. So what's left now to go outside the circles but inside the rectangle? So let's have a look. We've done 3. Let's cross that off. 3 and 9. We've done 21 and we've done 27. So what's left now, Asadullah?
1, 7,
1,
11.
7, 11, 17.
17, 23, and 29.
Fantastic. Where should we write those?
Outside the box.
Outside the circles, but inside the box, yeah?
Yeah.
1, 7, 11, 17, 19, 23, and 29. Okay, nice question to start us off on this higher paper. Now, okay, read the actual question, please, starting from here.
A number is chosen at random from the universal set. What is the probability that a number in the set A, what does the logo mean?
Okay, that's union
B.
B. So that means they want you to join the two sets together, set A and set B, join them together. If you join set A and B together, what do you get? How many numbers are there in there altogether then?
There'll be 7.
1, 2, 3, 4, 5, 6, 7 numbers. Okay. So the probability of being in the set A union B, there's 7 members of that set A union B. Obviously, they have to do it out of the universal set. So how many numbers were in the universal set altogether? So you got 7 up there, 8, 9, 10, 11, 12, 13,
14.
14. Have you missed one out? Yes.
13 is also an odd number. You missed that one out as well.
Thank you. We missed one out. Yeah, because 13 is up there, and for some reason I didn't highlight it, and we missed it out. Thank you for that, man. So that's right now. So you should have 15 on the bottom. So 7 out of 15. Okay, lovely. So somebody is awake today. 7 out of 15. Excellent. And that's the question done. And we need to, for good measure, put the answer on the dotted line. 7 over 15 finished. Nice and straightforward. Done. Okay, thank you for that. Mr. Asudullah, that was a fantastically done question. Simultaneous equation. Salih, you want to go for it? Okay, Salih wants to go for simultaneous equation. Solve the simultaneous equation. Hopefully, this one is a nice and friendly one. Okay, I think, let me get a second. I don't know why these are not lined up really. I think they have tried to line them up for some reason. Copy, paste.
Shall we write them?
No, I don't want to do that. Give me a second. Paste. Okay. And so I'm gonna put that second one there because they just look a little bit kind of misaligned. Give me a second. Copy that one. That's better. Let's move it a little bit that way. Yeah, okay. That's better. Here we go. So what do we need to do here, Saleh, for simultaneous equations?
We need to times them cross by 4. I mean, just hop on by 4.
We don't need to time anything at the moment. We need to eliminate either the x or the y. Now, because the x is already equal to each other, you can eliminate them by doing what?
Minusing.
By minusing them. So 3x, take away 3x is
0.
0x. Now 0x, we can write it down here, but we don't normally write it down. We just leave it blank because it's been eliminated now. Now, what is y minus 4y?
Just minus 3y.
Y minus 4y. Think about it carefully.
I'll be plus 5y. 5y.
Plus 5y, that's correct. And what's minus 4 minus 6?
Minus 10. I mean, yeah, minus 10.
Fantastic. So we need to work out the value of y. Don't ask me why.
Divide that by 5.
So we need to take the time by 5 over, becomes a divided by 5. Why is everything so thick?
So y equals minus 2.
Y equals minus 2. So we've eliminated the x's, we've worked out the y's. What do we do now?
Let's substitute it into the equation.
So we have to substitute this into one of the above equations. So we can substitute it, say for example, into that one there. Okay, we can copy it out from the top. Copy, paste. Oh, no, I think I've pointed to the y. Pardon me. Shouldn't be pointing to the y. That one should be then going into here, that part. And the bottom one, I can change that as well. There we go. That's better. So let's have a look. So we got 3x and we're going to add the y value. So we're going to basically add minus 2, which is same as saying minus 2 equals minus 4. So how do we work out the x?
3 times by minus 2, which is minus 6.
So now don't forget here, you have to rearrange and make x the subject, Talia.
Okay.
So we want orange. We want to make x the subject. So opposite of minus 2 is?
Plus 2.
So what's minus 4 at 2?
Minus 2.
And then what's the opposite time by 3?
Divided by 2.
Okay, now, if you left us 2 spaces on the bottom for the answer. Okay, so x is equal to minus 2/3. And then y was equal with y gone. Y was what? Minus 2. Okay, so please folks try to if you have the temptation, so oh yeah, this is going to be minus 0.666 blah blah blah. There's no need to change it into a decimal, and especially if you start if you have to start rounding it off and stuff. Leave it as minus 2/3. This is pure answer, and that works nicely for how we need to set the question out. Okay, question number 3 is a question about dress sizes. Okay, question number 3. Let's have Anaya please join me in question number 3. Thank you for that, Salia. That was a lovely question. We got the right answers. Question number 3, please. Anaya.
The table shows some information about the dress sizes of 25 women. Find the median dress size.
Okay, find the median. So what does the word, so the key word here is median. What does that word mean? So median sounds like what word? So median sounds like possibly middle. So the median dress size is the middle dress size. So how many dress sizes are number 8?
2.
And then if you go into the 10 dress size, how many more are they? Another?
7. No. Yeah.
So 2 add 9 is?
Oh, 11.
So we're doing cumulative, and then 11 add the 8 is?
17. 19.
19, and then 19 add 6 is?
25.
25, which is the total. Now, if you have 25 women standing in a line, woman number 1 all the way to woman number 25, you have 25 women. So if you do, for example, 12 women on this side and 12 women on this side, what's 12 at 12?
24.
24. So you got 24 women. So that means this woman here, which is going to be the 13th woman, she will be our,
Median.
she's going to be our median value. So by looking at the cumulative frequency, we need to find out where the middle value actually is. So the first 2 women are here, and then the next up to the 11 women are the 10. And if you want to go into the 13th, so the 11th, 12th, 13th, all the way up to 19 is here, which is in which group?
12.
12. Okay, so 12. Okay, lovely, that's done. Read the next part of the question, please.
3 of the 25 women have a shoe size of 7. So he says that if you choose at random one of the 25 women, the probability that she has either a shoe size of 7 or a dress size of 14 is 9/25, because 3/25 plus 6/25 equals 9/25.
Okay.
Is that correct? You must give a reason for your answer.
So what they seem to be doing, they seem to be combining 2 sets of data together. Now she's made a certain assumption by doing it that way. So what is it? So what could we say about that? So is she correct by making the assumption? So is she done something right, or is she done something wrong? So she's combining the dress size information with the shoe size information, but she's kind of missed out. She's overlooked one thing. What has she overlooked? Anything?
I'm not sure.
Okay, so what we say here that she definitely overlooked that the one person can actually be in both groups. So the key word that we're looking for here is this. So we say, first of all, is Zoe correct? We said no. No, she's not correct. Why? Because okay, the two things, shoe size and dress size, are not so she's missed out one assumption that she's made. She's made an assumption that they are. So we're saying no. Her statement is incorrect because they are not mutually exclusive. She's made them mutually exclusive events. So one person in one group can also be in the second group. So that will actually change the fractions, and that's the bit that she's missed out for question 3, part B. Okay, thank you for that. Can you do one more question for me, please? Number 4.
Daniel bakes 420 cakes. He bakes only vanilla cakes, banana cakes, lemon cakes, and chocolate cakes. 2/7 of the cake are vanilla cakes. 35% of the cakes are banana cakes. The ratio of the number of lemon cakes to the number of chocolate cakes is 45. Work out the number of lemon cakes Daniel bakes.
Okay, so these ones are vanilla. These ones are banana. So the minions will be really happy. And then we have the lemon, and then we have the chocolate. Okay, so 2/7. What's 2/7 of 420? Let's work that out. So what's 2/7 of 420? So we do 2/7 times by 420 on the calculator. Okay, feed the answers back into the chat, please, everybody. Everybody have a go on the calculator, please. Don't shout out the answer, Sadia. Everybody give the answer. Nobody can see each other's answers anyway. Okay, I'm just saying before you shout out the answers. Okay. Right, next one we have 35% are banana. So 35%, we can put it as a decimal multiplier, 0.35 times by 420. So 0.35 times by 420 gives us 147. So first of all, can you tell me how many cakes are left over on this side then? So Anaya, we have 120 vanilla, 147 banana ones, and the rest of them, that makes the total of 420, will be lemon and chocolate combined. So how many are in that last section? How would you work it out?
You minus vanilla and banana by lemon and chocolate.
So we have 420 minus 120, add 147, and that'll give you the answer there. Okay, who's worked that out? Please work that out. Put the answer into chat, please. 420 minus. We've got some answers coming through. Okay, well done, Ismail. Okay, what about the rest of you? Asadullah got 153 million or something. Okay, 150. Okay, so both the answer, Abdullah. Okay, excellent. So we got 153. Now it says here, so the lemon cakes and the chocolate cakes, these two here, they're shared in a ratio of 4:5, and they want to know how many lemon. So let's for the lemon. Okay, lemon. So for the lemon ones, the ratio is 4/9 of 153. So let's put that in the calculator. So we have 4/9 Okay, was everybody have a go at that question, please? Give me some answers back. Okay, I'm getting answers from 1 or 2 people. I don't know what the rest of you guys are doing. Okay, Anaya's giving me an answer. Salia, yeah, I can see your answer, lovely. Okay, Eliza, Asadullah, excellent. So we get a nice answer of 68. Finished. Put the answer over here. Okay, lovely. Okay. Question number 5. Polygons, internal and external angles. Okay, Abu Bakr, you want to have a go at this one with me?
Okay, sir.
Read the question for me.
Okay. In the diagram, AB, BC, and CD are 3 sides of the regular polygon P. Show the polygon P is an hexagon. You must show your working.
Okay. Okay, right. So we have to show. So when it says show that the polygon P is a hexagon, that's in between the square and the other square and the regular 12-sided polygon and inside, you must show you're working out. Now, what defines a hexagon?
This what it called, the number of sides it has on the shape.
Regular. So the regular polygon. So it's a regular hexagon. So if we think about a regular hexagon, let's have a look. Let's see what we know. So what do you know about the internal angles?
The internal
What does that add up to?
360.
So how many sides does a hexagon have?
Hexagon would have 6.
So if you want to work at the internal angle sum of for example, of a hexagon, you do 6 minus 2 is 4. So you do 4 times by 1/8. I'll tell you what all the angles add up to inside. Oh, but this is one way of doing it. I'll show you a different way as well, which is quicker. And then what's 4 times by 180?
It's 720.
720. Now you got 6 equal angles.
6. Okay, so you have to divide that by 6.
So that gives you what?
120.
So this angle here of a regular polygon should be what?
This angle 120.
And this one in here should be what?
90.
And this one here, we got to work it out. Now that's one way of working out the internal angle, but we can also do it a quicker way. Ismail, can you tell us what the quicker way is, please?
I don't know.
Okay, so if you want to look at a hexagon, and I do this to it now, what's this angle here called? The red one?
Is it 180 minus the one that's inside? Oh, extend.
The external angle. So how do you work at the external angle? What is the external angle?
180 minus the one that's inside.
The external angle is always 360 divided by n.
Oh,
No, yeah, that's what you're saying is right, but we don't know the internal one. I'm just saying if you're starting it graying from the beginning.
okay.
So you do 360. If you divide it by 6, so that what will that give us?
60.
60. So now, tell me what you just said. So the internal and the external always add up to?
180.
Well, the external one, which is the one that we just worked out, is equal to 60. So what's the internal one going to be?
120.
There you go. I think this is a little bit shorter than the top calculation. What do you think, Ismail?
Yeah.
Yeah, the top one's got quite a bit more calculation. So you can you do either way. So that's like method number 1 for working at angles. This is method number 2. You start off, this is starting off on the inside, working out. This is starting off first from the outside, then working towards the inside. It's totally up to you, whichever way you want to do that particular question. Now, for a regular 12-sided polygon, we can do again, which method should we use now for this is for the hexagon, by the way. So for the 12-sided polygon now. So for the 12-sided polygon, we need to work out what this angle here is B. How do I work that out?
360 minus 120 plus 90.
So we need to do 360 divided by,
Oh, okay.
Okay, what's 360 divided by 12?
30.
So 30 will be this angle here, by the way. It'll be that angle is 30.
Hmm.
So what will the
Okay.
inside one be then?
150.
Exactly. So 180 minus the 30 on the outside will give you 150 on the inside. And that's going to be equal to angle B. Okay, lovely. Now let's put that diagram together. Give me a second. Let me just actually rub this stuff out from here. And let me just cut a piece of this diagram out. Copy. Okay. 90. What's this angle again?
150.
And this one is 90 degrees. Now we need to work out this angle here. So this
The 120.
A, B, C, D, that will be, what is it?
Isn't it 120?
It's supposed to be 120, but how do you work it out from the diagram for me, please? What is the angle from here? So it says the
It's already
question mark is
360.
equal to 360 degrees minus
90 plus 1.
150 and minus
yeah.
90 degrees. So it is equal to
120.
360 minus 240, which is actually 120, absolutely right. So then is polygon P going to be, that's also going to be same. That's also going to be 120 as well. So is it going to be hexagon then?
Yeah.
Okay, so give me a little statement now, please. Let's kind of polish it off. So give me a little statement that brings those two pieces of information together. So we're going to say in order for polygon P to be a hexagon, the internal angle at ABC needs to be what? 120.
120.
And we can, from the above calculation, it is equal to 120. Yes?
Yeah.
Let's write that down. So in order for the polygon P to be, so I'll write this down, to be a regular hexagon, angle ABC, which equals angle BCD, equals 120 degrees. As we can see from the calculations, that angle ABC is indeed 120 degrees. Done. So we've got to know what's expected from that particular angle. That angle at ABC needs to be 120, which is the same as the angle at BCD as well. So these two angles are the same. Okay, lovely. Hopefully you guys got that all done. Okay. Question number 6. Similar to a question in terms of style to what we've done in the previous papers. I'm going to see which person remembers which question we've done. So let's have Eliza, please join me on this question.
The density of an apple is 1.05 grams per centimeters cubed. The density of fruit syrup is 1.4 grams per centimeter cubed. The density of carbonated water is 0.99 grams per centimeters cubed. 25 centimeters cubed of apple juice are mixed with 15 centimeters cubed of fruit syrup and 280 centimeters cubed of carbonated water to make a drink with a volume of 320 centimeters cubed. Work out the density of the drink and give your answers to the correct 2 decimal places.
Okay. Now, where else in your school do you hear the word density? You don't normally hear it in maths. You hear it in which subject?
Science.
Yes, fantastic. So density. So the green values, what are those? So density is grams per centimeter cube. What's the centimeter cube talking about? What's that called? So density, and the clue is this word here. What are the green values?
All the volumes.
All the volumes. So what's missing when we talk about density in physics?
Um,
Because density is a formula.
Mass.
Density equals mass. Give me the formula.
Times density. Density equals mass times
Or
Acceleration.
formula or volume.
volume equals mass times density.
Yeah, density equals mass divided by volume.
Yeah.
Okay. So the one that's missing is the mass at the moment. That's not been talked about. Now, it says here, work out the density of the drink. So they got 3 drinks. They mixed it together to make like a master drink. And now they want you to work out the density of the new drink. Now, you remember in the previous question, maybe we had, I think we had 2 or 3 parts of a journey from something to London to Manchester.
yeah.
And we done the question like this. We said speed is equal to d1 plus d2 over t1 plus t2. So all the distances divided by all the time to give us
Yeah.
an average speed. So in this particular question, what do they want us to work with the density? They want us to work at a similar style of question as what we've done before. So not a density, but an average density. So the density average. So the density average will be what? Mass of the apple juice plus the mass of the
carbonated water.
mass of the oh, that's too big. Mass of the fruit syrup plus the mass of the carbonated water. That's one. Divided by what?
The volume of the
Apple juice plus
yeah.
the volume of the fruit syrup plus the volume of the carbonated water. Is that right?
Yeah.
Okay, lovely. Now, so let's have a look what we know, what we don't know. So at the moment, do we know any of the masses?
No.
Do we know the volumes? Yes.
Yeah.
Lovely. So what volume? So do we know the volume of the apple juice?
Yeah, 25,
And the volume of the fruit syrup?
15, and 280.
Okay, now. Okay, so what do we need to work out then?
The masses.
We need to work out the masses. So the masses we don't know. Now, if we look at this original formula here, how do I work out the mass from the formula?
You do density times volume.
Opposite divide by the volume is times by the, so then the density times by the volume equals the mass. That's the variation of that formula. So we need to work out the masses for, the masses for those juices. So we can put them into the formula and as small mini calculations. So let's go for it. So we can put it over here now, and we can copy that over here. Okay, and then we can, okay. Right, so if I want to work at the mass of the apple juice, what two things do I need to look at?
The density and the volume.
The density, what's the density of the apple juice?
1.05 grams.
And what's the volume of the apple juice?
25.
Let's just pop that in a little bracket there. Now, what's the density of the fruit syrup?
1.4.
And what's the mass, so the volume of it?
15.
So we actually put in the calculator, rather than looking at them as separate, then putting them in, we just literally lobbing the whole lot in there because we can, and it's quite straightforward. It's not like multi-step. So what were the density of the carbonated water?
0.99 grams and 280.
280 is the volume, yeah?
Yeah.
What's the volume of the apple juice?
The volume of the apple juice is 25.
And the volume of the fruit syrup?
15.
And the volume of the carbonated water?
280.
Okay, so that's all those volumes. Now we need to smack this into the calculator. So let's grab our calculators. I got my calculator right here ready. So I'm going to use the brackets as well. So 1.05 times by 25 close bracket plus open bracket, 1.4. Come on, everybody, get your calculators, get busy. Time by 50. I want answers as well in the chat. Plus 0.99 time by 280. Oops, I think I missed the bracket out there. Let's go back. Okay, and okay, I went too far. Time by is 280. Okay, I think I need to go back by 1. And AET, close the bracket. Replay, bring it down to the bottom. So we have, it's 320 at the bottom, isn't it? Or that's 320 because they all add up to a volume of 320. We could have put 320 in the bottom, yes. So we can put 320 in straight away.
Yeah, that's 220.
Okay, so that gives us that answer there.
1.16.
Okay, now I'm gonna write my original value down. I like always my original values. 6489 divided by 6,400, which looks like something strange and mad. Okay, now that is not really acceptable for you to put that down as an answer, really. You should be giving that now. What button do I press on the calculator, Eliza?
The S to D.
The S to D will convert our fractional answer into a decimal answer. So let's write the decimal answer down, 1.01390,625. Now, does it tell us, oh, here, lovely. It's given us here an indication that it wants us to do it to 2 decimal places. So can you use that for me for 2 decimal places?
Yes, it'd be 1.01.
So 1.01, because you look at the 3 that's less than 5, so you leave everything alone. And that is our final answer. Fantastic. Well done there, Eliza. Thank you. So that's the question which has a similar style to a question we done in the previous paper, where we had multiple parts of a journey and we had to work out the average speed over the multiple parts journey. So we had to do the distances for each part divided by the time for each part. So similar to this. So the masses for each part divided by the volumes for each part. So the total mass on top and the total volume on the bottom. So we could have just put 320 on the bottom, but it's okay, we've done it separately. Put that in the calculator. Calculator's given an answer. We round it off. Fantastic. Lovely. Question number 7 is a, right. Put in the chat, please, what type of topic this is. Everybody, no shouting out anybody at all. Everybody, and you as well, so type it in. Everybody type in. Nobody else can see the, your answers anyway. Only I can. Okay, Abu Bakr, you are close but not correct. Ismail, well done. Abdullah, well done. Eliza, well, oh, Eliza, no, Eliza, not. You wouldn't be using Pythagoras if you only got one length. Same, so Layla as well. So that's Layla. Okay. Oh, okay. Abu Bakr, your new answer is better. Salih, what's your answer? Do you give an answer? What is it? Yeah, that's the one. I have to give you the answer here. Where's your brain cells gone? It's gone on holiday. Okay, second. Okay, Abu Bakr, yes, you're welcome. Okay, Abu Bakr, join me on this question, please. Right, go.
ABC is a right angle triangle. Calculate the length of AB. Give your answer correctly 3 significant figures.
So what is the first of all the key word in the first key 2 words in the first sentence?
A right angle triangle.
Okay, now the right angle triangle, you have to make sure your brain clocks those words, because a right angle triangle there means that you can use what 2 techniques?
Trigonometry and the sine. No, trigonometry and sine rule, or is it Pythagoras?
Now you wouldn't be using sine rule on a right angle triangle. Sine rule and cosine rule are for non-right angle triangles. So the moment they mention right angle triangle, you straight away, like, you are in your math toolbox in your head, and you got in one hand the trig, and another hand you got Pythag. So you got those 2 possibilities. So first of all, let's label the diagram. Now the side which is opposite the right angle, what do we call that side always?
Hypotenuse.
Absolutely. Now the side which is opposite the angle given in the question, what's that side called?
The opposite.
Absolutely. What is the leftover poor, the poor side that's left over at the last?
The adjacent.
Yeah, the poor Jason, he's always the last one to be labeled, and that's just how it is. Tough. Now, what side do they want us to work out?
They want us to work out this opposite.
Absolutely, they want us to work out A to B, calculate the length of AB. So if you look at this particular question is between, what do we know in this question? We know the hypotenuse, and we want to work out the
Opposite. So we'll be.
So now,
we'll be
before you start giving me the value, I want you to tell me first of all, if I put those O and H together, can you sound that? What sound does O and H make?
Oh,
and come from what?
so
Fantastic. That's absolutely exactly how you do the question. So your question is an OH question. Comes from sa. So now give me the formula triangle for that then.
sine equals opposite over hypotenuse.
Absolutely. So we put into a nice little formula triangle. So remember, we started our question from here. Then that told us, oh yes, it's that one. Then we went to the triangle. Now we want to work out the O. The O is the bit that we don't know. So I'm gonna get my finger. I'm gonna cover my finger with the O because we want to work that out. So there's my little finger there covering it up. Now that's telling me what to do now. So if I cover up the O, what do I have to do to work it out? O equals?
O equals sine 23.
Time by?
15.
Okay, so I'm gonna write down the formula first, then I'm gonna put the values in. That's not a problem. You've done it first. So sine of 23 time by the 15 is equal to O. So we can get on a calculator now. So we press sine and 23, we close the bracket, then we multiply it by what number is it? 15 or something? 15, yeah. Okay, my 15 looks a little bit not very good. So let's make 15 look more clearer. Right, everybody get the answer done and put the answer in the chat before I give you my answer. Okay, I'm saying for you as well, Abu Bakr. Put your answer into the chat first. I want to see everybody's answers. Everybody, wakey time, calculation time. So I've got Abu Bakr's answer. Okay, just put your answer in. Doesn't matter, just put the first couple of digits in, put it in, type it in. Eliza's answer, I got Abdullah's answer, I got Asadullah's answer, and the one with the 3 significant figures of Asadullah, your answer is wrong because you're giving me too few digits. Anaya, that's good, you calculate the answer. Anaya, can you give me 3 significant figures now? Asadullah, give me the figures again, back to 3 significant figures. Okay. 3 SF. So I'm gonna write down my answer now, which you can see on the board. So my O value opposite, which is actually the length AB. Okay, that looks like a fruit or something. Okay, O. So I've got here from the screen 5.860966 blah 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 blah. It wants me to do it through 3 significant figures. Let's have a look. Layla, your answer. Whoa.
I have the wrong thing in the calculator.
Okay, Anaya, your answer is too big. Anaya, you've got 4 significant figures. So you have 1, 2, 3, and you stop there. You look at the next digit, and it's less than 5, so you leave it alone. So the answer becomes 5.86 exactly. Okay, 5.86. That's better now. Your second answer is better. Okay, lovely. So I can see some nice. Abu Bakr, what was your answer, Abu Bakr, for that? The calculation. Yeah, you got answer in there.
Yeah, so I wrote 5.86.
Fantastic. That's lovely. Then it's good. Okay.
Thanks, guys.
Question number 7 is done. MashaAllah, you've done it very nicely. You understood the labeling. You understood the and the comes from sign and how you manipulate that. Fantastic. Lovely.
Thanks, sir.
Okay, no problem at all. Question number 8. Oh, this one looks nice. I think I drew that circle just to help me earlier because I was thinking how we do the question. Question number 8. Let's have Layla, please.
Sorry. A square with sides of length x centimeters is inside a circle. Each vertex of the square is on the circumference of the circle. The area of the circle is 49 centimeters squared. Work out the value of x. Give your answer correct to 3 significant figures.
Okay, right. So what's it telling us? It's telling us that the square has a length of x. Okay, let's put that in. Okay. So we're gonna choose that one here. That's x, 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 and x. Okay, dokie, lovely, lovely. Okay, and the work out the value of x. Now, so can you tell me what goes from here to here?
The 49. No,
That line's called the
diameter.
And if I do like a halfway house, what will it be called then?
The radius.
Okay, so that's the center of the circle, yeah? So we know that the, okay, all right, so I think we should label R on there. And we label R on here as well. Okay, now we know the area of the circle is 49 centimeters squared. Oh, hang on a second. That's R, that's R. Okay, and this is also, we want
Yeah, on either side.
what do we work out? We want to work out the value of x in there. Yeah, that is also R, that's also R as well. But I don't think we need that particular one. Oops. So tell me what you know about this bit here. They've told us that the area of the circle is 49. So what does the area of the circle mean to you? What's the formula for the area of a circle?
Pi r squared.
And then what's that equal to in this case?
49.
So how would we work out the radius from that then?
You do the square root of 49, which is 7. Oh, first you divide it by
Remember,
pi.
that's the first action. That's the second action. You must move the. So it's 49 divided by pi first of all, yes?
Yes.
And
then root it.
okay, let's use a calculator. Okay, square root, fraction button inside the square root. We got 49. Replay.
Shall I read it out?
Okay, what was there? Oops. Uh-oh. Shift. Okay, don't read that yet. I want everybody else to have a go. I think we got too many sleeping pirates in the class. Everybody's like sleeping. They're waiting for somebody else to give the answer. So we got a radius. I don't think I'll give mine that to it quickly. So we got 3. Well, what's your radius, Layla?
3.94932708. Yeah, it's the same as yours.
Okay, 3.9493, blah, 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 blah. Okay, remember, I don't want anybody rounding anything off. Yeah, that's well done. 32708.5 for the moment. Okay. So if we know the radius and we need to work out the x, let's have a look now of that diagram. Let's cut that part out. So we're gonna have this part, and then we're gonna have this part and this part. Okay. Now, okay. So if the radius is equal to that, what's the diameter equal to then? We have to then what? If you want to work out the diameter, what do you do?
Half it? No.
Okay. So we know what the hypotenuse is. What do you know about these angles over here?
90 degrees.
90 degrees is the other one in the corner. If you split a 90 into half, what do you get?
They're each 45 degrees.
Fantastic. We've got angles as well. So we need to work out the x. I don't want to label that as well because it'll be a little bit confusing, the diagram. So I'll take the other x off for good measure, just to make sure that we're not getting confused. So now, how would you work out the x now? What would you do to it? So
I can't remember what it's called, but you have to.
So let's look at the previous question. We have 2 names that we could possibly use.
Trigonometry and Pythagoras.
You got trigonometry and Pythagoras theorem. Let me actually copy those out. Let's borrow them. Pop them over here. Okay, so which one shall we use then? So we have an angle, we have a length, and we want to work out the other length. It looks quite similar to what Abu Bakr just done, literally identical. So are we going to use Pythagoras or are we going to use trigonometry?
Pythagoras.
Okay, now remember you have an
Yeah.
angle.
Never mind, trigonometry.
Trigonometry, absolutely. So opposite the angle, what's that side called?
The opposite.
Yeah, you're supposed to say the opposite.
Yeah.
Okay. So then the opposite the right angle is the
Hypotenuse.
or the hippopotamus, and the leftover side is the
Adjacent.
fantastic, lovely. Okay, let's get an orange. So our question is between the opposite that we need to work out and the hypotenuse that we have. So can you please sound for me the O and the H? What sound does that make? Oh. And the comes from? So. So in this particular case, last case, we use the same one.
Yeah.
So we use sa. Okay, let's use sa again. Okay, I think it's getting a bit too big. Okay, so let's put this down. S-O-H, angle. Okay, now we want to work out the O. So we get our little finger. And we cover up the O with the finger, and that tells us what to do with the rest of it. What's it telling us to do?
You multiply your angle and hypotenuse.
So sine of 45 times by the hypotenuse. Now, don't forget the hypotenuse is still in my calculator. I haven't rounded it off. I haven't done anything to it, blah, blah, blah. So let's reuse it now.
Yeah.
So I want to type in now sine of 45, close the bracket, multiply by the answer. So I'm reusing the answer stored in the calculator's memory from the previous 5 seconds ago. And then we press equal. So that gives us now an answer for x is equal to
5.59.
5.5851. Let's write them down first. Okay, and they want the answer to 3 significant figures. So unos, dos, tres. We're going to stop there. And we've got to look at the 5. So what do we do to the 8 then?
Round up to 9. 5.59, yeah.
Okay, so give us the value of x. So do we say 5.59 what?
Centimeters.
Absolutely, because it's the length. So they haven't put the centimeters there for free. We have to write down ourselves. Otherwise, it could be 5.59 anything. 5.59 bananas, pakore, samosa. It could be anything 5.59. It could be 5.59 millimeters or kilometers. Okay, that's lovely. Well done. Okay, we got literally the last 5 minutes left. I don't know whether we'll be able to finish that whole question in the 5 minutes. Okay, I think we'll come back to question number 9. I think we should do number 10. That deserves our attention in the last few minutes. Okay, right. Let's have, who should we have next? Abu Bakr, are you okay with compound interest?
Sure, why not? I'll have a go at it.
Okay, if you're not quite sure, I can grab somebody else to do that question. That's not a problem.
Okay, grab someone else.
Okay, no problem. Okay, let's have for that question, let's have Abdullah, please. Number 10.
Now we invest £6,000 for 5 years. The investment gets compound interest of X% per annum. At the end of 5 years, the investment is worth £8,029.35. Work out the value of X.
Okay, lovely. So remind us what we've been doing over the last couple of lessons. We've done compound interest. What's that lovely formula?
It's the original, so
Principal
times the decimal multiplier to the power of time.
Yeah, that's true. Yeah, sorry, I don't put it, but that's right, time. Okay, equals the compound interest, yeah?
Yeah.
And actually here, the time we could put it in specifically is the number of years. Okay, lovely. So what's the principal amount?
£6,000.
So that's the money we start with. So £6,000. Now the decimal multiplier, we're just going to leave it as DM for the moment. How many years do we have it for the investment?
5 years.
And what's the amount of money left at the end of the 5 years?
£8,029.35.
Okay, lovely. Now at the moment, the X% is actually hidden within the DM. We're gonna pull that apart at the end. So the DM, the decimal multiplier, includes the X, but we're not gonna confuse the algebra for the moment. Try to keep it a little bit simple. Okay, lovely. So how do we work out? Let me grab an orange. How do we work out the decimal multiplier which contains the X? How do we get to the DM? Can you lead us through the steps, please?
It would be 1 point.
No. Tell me the steps, please. What do we do? So DM is being to the power of 5, then it's been times by 6,000. So which one shall I move first to make DM the subject?
The 6,000.
Fantastic, because that's the second action. The first action is the power 5. Opposite of time by 6,000 is?
Divided by 6,000.
So the decimal multiplier, and then what's the opposite of the root of the power 5?
Root 5.
Okay, so we're going to do, first of all, divided by 6,000, that came over first. Then we're going to root it to the power of 5. So I want everybody on the calculators, and I'm going to wait till you guys send me your answers before I press equal on mine, hopefully this time. So square root, fraction button. Oops, no, not square root. Okay, let's go back. We need the 5th root. So we press shift, this button, this one here. Then we press 5 on the outside, and then we press replay, get it to the inside. That looks better. Sorry about that. I was a bit too excited. No, got the wrong number. 8029.35, and then we divide it by 6,000. I press equal too quickly. Okay, Layla's already given me an answer. Abdullah's already given me an answer. Inaya's giving me an answer. Okay, lovely. Okay, what do you get, Abu Bakr, for that calculation? I need you, don't look at my answer, look at your answer. You need to be able to use your calculator properly. So Asadullah has given me that number. Okay, let's write the number down. So our decimal multiplier is equal to 1.059999, blah, blah, blah. So now what do we do to it? For turn it from decimal multiplier into a percentage,
Times by 100.
we times it by 100. Well done. So go boom, boom. So we get 105.999%. So can you run, so that would be what? That is the same as saying 106%. 106% if we round it off to 3 significant figures. Now, the X% is where? So we have 100%, add X% gives us our 106%. So what's X going to be then?
6.
Done. Sealed. So there's the answer. So they want to know how much percent is the per annum, compound interest. So within the decimal multiplier, you have that kind of wealth of information. You have the 100%, at the X% gives you the decimal multiplier, which has been converted back into percentage, is equal to 106. So fantastic. So that gives us a 6%, and that brings us neatly to the end of our lesson. And that's the way we're going to stop our recording as well.